Hello, geometry students. This is Notes 11-2, and it's going to cover solid figures and a little bit of cross sections and nets from these. So if you would, go ahead and get some paper. You'll probably need 3 or 4 pieces of paper just to be sure. So go ahead and pause the video now. Go ahead and get some paper and some writing instruments so you can fill out these notes with me together. Start off, let's just talk about what we mean by a solid. A solid is a 3-dimensional shape. And of course, we're all familiar with the shortcut abbreviation 3D. So we're talking about something that has 3 dimensions to it. 3 dimensions meaning that it's going to have a length to it, a width to it, and it's going to have a height to it. Up to this point in geometry, we have dealt with triangles and squares, pentagons, circles, everything that was that could fit on one flat surface. These, of course, are all examples of 2-dimensional shapes, or 2D. What we're talking about in this one will be something like a cylinder, okay? Something that has length to it, width to it, and height to it, or a cube. This is not a square, this is not a circle. We can look at the faces of these and see circles and squares, but when we hold that shape, it doesn't fit on a flat surface. Okay? So this is what Chapter 11 is going to concentrate on. We're going to go through, and look at things in 3 dimensions. So let's go over some vocabulary here. We have vocabulary just about every unit, just to make sure we're all talking about legitimate math terms. So first of all, I want to go over to you what we mean by a face. And a face is a flat, polygonal shape. That will be the surface of the polyhedron. Oops. Flat polygonal surface. That's going to be on our polyhedron. Okay? So when we talk about a face, you're familiar with this shape right here. It's the good old pyramid. And when I look at this piece right here is the face. It is a polygon, and it is on the surface, and of course it is flat. I can look at this pyramid, and this pyramid has a bunch of triangles that are faces. It also has a square that is a face. So this surface right here is called a face. This is a face. This is a face. Okay. Next term I want to talk about is an edge. Okay. Flat surface was the face, an edge is going to be a segment. And that segment is where 2 faces meet or intersect. So I can rub my hand along this face here and this face here. Those 2 faces are going to meet at this edge. I can run my finger along an edge. This is the edge where this face and this face meet, where the square and the triangle meet. Another example is this edge here. I can run my finger along this edge. This face and this face meet to form this edge. Next term is a vertex. Yes, it's that same term we used when we were back up here and we said this is a vertex of that triangle, this is a vertex of the square or rectangle, and this is a vertex. Okay. And when we talked about it in 3-dimension, it was where two of the edges of these shapes met. When we talk about it in 3-dimension, it's also going to be a point, but this is a point where 3 or more edges meet. So you can see here on that same pyramid that we had, where this edge, and this edge meet, they're all going to one spot right here, and that is a vertex. 1, 2, 3 meet to there. If we look at this one, which some would say if I had it setting here would be the top of this pyramid, you can see 1, 2, 3, 4 edges that meet there. Okay. So make sure you have this written down in your notes, these definitions. Sorry about my scribbling sometimes, but again, make sure these are on there. Just a note, I will be collecting these notes when you guys return to school, so make sure you have these so you can get full credit. Now, when I look at these faces, edges, and vertices, I want to talk about naming them. Okay? When we name them, we're going to name them by their shape. So if I want to name this shape here, I'm going to name it by its vertices. Okay? So if I'm going to name, in this case, the face of this, let's say this is point A, this is point B, here is C, and then we have D here. Those would be the points that would make this square base. So I would name that base, or excuse me, that face, square A, B, C, D. It's a parallelogram, so I might even use that parallelogram symbol and say it's parallelogram, A, B, C, D. But I name that face by all of its vertices, just like I would name this square, square A, B, C, D. We name the face by the shape of it. On this same shape, if I labeled this point here, this vertex here, let's make that point E, then I would have a face over here on the left-hand side that is a triangle. And I would say that left face is triangle DCE, or any combination of that. And hopefully you could see I would also have CBE, ABE, and ADE to name all of the faces of this shape. If I'm naming an edge of course is just a segment, so I could just name this segment here that connects C and D. This would be segment DC. This edge here, DE. This one, CE. Down here, we would even have BC. So again, the edge is named by the endpoints of that segment. And of course, those endpoints are each a vertex. Each one of these vertexes or vertices would be point A over here, point B down here, C, D, and E, and so on. Okay? So now we have learned to name each one of those. Next, what I'd like to do is talk about the different types of solids that we're going to go over in this unit. So these are the types. in no particular order. We're just going to kind of name these out. So first of all, I have a general term called a polyhedron. Okay? A polyhedron is a solid whose faces are all polygons. It's just a general category. This is a polyhedron because you have triangles on these four faces and a square on the bottom. This is also a polyhedron because it has a triangle here and there on the top and the bottom, and then on each side it has rectangles. All of these shapes are polygons, therefore this is a polyhedron. This is not a polyhedron because this circle is not a polygon, this cylinder. Okay? So again, this is a general term that we have for all of the shapes whose faces are all polygons. Now, within this group, we have a shape called a prism. And a prism is one of these polyhedrons that always has, so I'll just say it's a polyhedron, so it matches those things that we had up above. But it's a polyhedron that has two parallel and congruent faces. Okay. Time to write that down. A prism is a polyhedron that has two parallel and congruent faces. That's the key in this definition. Obviously, it has to meet those conditions that every surface is a polygon, but it's going to have two parallel and congruent faces that are congruent to each other. Okay? So let's take a look at this shape here. This is a prism. Many of you from science class may have had one of these shapes and you refracted some light through it. So it's a familiar shape of a prism. But in geometry, the reason it's called a prism is because this triangle here is the exact shape and size or congruent to this triangle here. Not only are they congruent to each other, but those two triangles are parallel to each other. When you have two parallel and congruent bases, this is a prism. This cube is a prism because it has two squares that are parallel and congruent, and even this one right here. This shape here has a hexagon that is parallel and congruent to another hexagon. Parallel and congruent bases make this shape, and this shape all prisms. Another type of polyhedron is a pyramid. And you've already heard me use that term with this shape. Okay? This is a pyramid. It is not a prism. With the prism, it had two parallel bases or faces that were congruent to each other. In this one, a pyramid again is a polyhedron, but this polyhedron is one that has one base and all other put this here, and all other faces meet at one vertex, and all other faces are triangles. In this shape here, you can see we have only one base, and then the remaining faces all meet at one vertex. And each one of these faces are indeed triangles. Triangles you can see on this shape, but they don't meet at a single vertex. None of these are pyramids. This one is a pyramid. I have another shape here, but bigger to show you. Okay. This one is a little bit bigger than that, but hopefully you can see from this one that all of the faces, other than the single base, will always be triangles. Okay. They meet at a single vertex here, which the way it's put or placed is on top. Obviously I could flip it over and it could be on its side or on the bottom, but this is a pyramid. Okay. This one is a pyramid. It happens to have a single base that is a triangle, and then all of the other faces are triangles. Okay. So these are two of the main types of polyhedrons that we want to work on. Okay? Now the next shape is not a polyhedron. It's a basic shape I know you're familiar with, and of course it's the solid that has two parallel and congruent faces that are circles. And we all know what a cylinder looks like. It's just a can. Okay. Has the two parallel and congruent circles, and then the other surface is actually a rectangle that gets wrapped around each one of those circles. So we have a cylinder. And then we also have a cone. And a cone is a solid figure with one base and only one base that is a circle. And all the other surfaces meet at a single point. So obviously you guys have seen a cone before. You've been to Flubs, you know what a cone is. All right? So that is our cone. And then finally we have our shape of a sphere. And a sphere is what a grade schooler would just say, hey, that's a ball. Okay? That circular shape, like this guy right here, that has a single point, and in geometry terms, it's all the points in space that are equal distance from one point called the center. Okay? These three guys here are not polyhedrons. None of these are polyhedrons because they do not have all of their faces as polygons. Okay? Now, let's talk about cross sections. Adjust things here a little bit and start another page. So let's talk about what we mean by a cross section. For each one of these solids, or any solid, I can take a plane and intersect it with that solid. The result is the intersection. And remember, a plane is just a flat surface, just like this piece of paper is a plane. The intersection of a plane and a solid will always result in a cross-section. Okay? Now, what you might need is a little visual, and I've got a couple of visuals that I want to help show you. I could have this shape right here. It's a three-dimensional shape. Actually, it's this same shape here. We don't have a name for this. This isn't really a cone or a pyramid, but it's a solid shape. Anytime I have a solid shape, I can create a cross-section. And what we mean by a cross-section is, again, an intersection of this shape and a plane. So I'm going to go ahead and take this piece of paper, and I'm going to go ahead and intersect this shape with a plane. Let me adjust it just a little bit, sorry. Okay, so imagine that this is a plane, and the plane intersects this shape right here. Okay. A plane, of course, is just a piece of paper that I have here. It's a flat surface that I've used to split this. Once I do this, I have created an intersection with this piece of paper and the shape. Now I've cut it and peeled it away to help you see that the shape that I'm talking about, the intersection, is this flat surface there, and believe it or not, out of this odd shape, the cross section is a triangle. Okay? And just the way this one is made, anytime I create another cross section, I create another triangle. This one actually happens to make bigger ones as I go towards this highest point, and then they're going to be smaller and smaller triangles. But if I were to cut this one in anything parallel to this, or excuse me, perpendicular to this piece of paper, every single one of those is going to have the shape of a triangle. Okay? The shape that I'm holding in my hand is not the cross section. The flat surface that I get when I cut this is what's called the cross section. Okay? So I want to draw a couple quick examples for you. So if I had a cone, say I have a cone that looks like this. I'm drawing this in 3 dimensions. And then I came through this cone and I sliced it right through here, parallel to this base here. Okay? Had this cone and I sliced it right through here. The result is going to be a cross section that's going to be the shape of, if I cut it parallel to it, it's actually going to form another circle. For example, this right here, okay, you can visualize I cut the top of this cone off, and this circle is the cross section. So that's hopefully that helps you kind of see that one. If I have other shapes, such as a triangular prism, this guy right here, and I cut parallel to this base, I'm going to get a cross section that is also a triangle. I've got a little example here to help you see that. This one here is the base, and I've sliced it this way. The shape that I see, this triangle, is the cross section. Now, if you can see in my examples, I've tried to cut it so that it was just like the base. But you can see in this example, it's a little dirty, apologize for that. But this one was cut not parallel to the bases, but just right that when I cut it, I created another triangle. Now the triangle doesn't look like these, but it is pretty similar to it. Okay. Now, this is a little bit dirty because I can also visualize not cutting it this way, but if I were to cut straight down this way, I were to slice right through this, hopefully what you can see is I would end up with a shape that actually would be a rectangle. So I can even take this shape and create something other than a triangle when I cut it. And of course, anybody who's cut carrots before knows that, one way you cut that carrot, I've got a carrot here, and I start slicing it, and every time I slice it, I get nice, beautiful circles for my cross section. Okay? Now, if you have cut carrots a little bit more on the dais, okay, so it's not parallel to that, you know that then you get a cross section that's looks like this, an elliptical shape. Okay? So it depends on how you cut it, what shape you will get. So let's take a look at a cylinder, and let's see what would happen if I did a cross section of this cylinder. Okay. I'm going to look at two main shapes that I could get out of this. If I decided to cut it this way, so here's my knife, and I'm going to cut it, and it's going to be parallel to the base here, and I'm going to slide this nice knife right on through in this direction. Can you see what shape that would get? As I slice this off, if I was nice and parallel to both of those, I would just end up with a cross section. Now I'm looking at this down from the top, and I would just get a circle. Let's take this same cylinder, center there, center on the bottom, and this time if I chose to go down and slice it from the top on down like this, I took my knife blade and cut right down through this like this. What shape are we going to end up now? Oops, I have to make that dotted. Hopefully you can see what would happen when I cut this one is, looking at it from the side this way, I would get a perfect shape of a rectangle. Okay? So your cross sections are always going to be dependent on how you make your cuts. Your cuts could form a shape that's already seen in it, or it could create a totally new and different shape when you do your cross sections. Okay? Now, next I want to talk about something that you had been introduced with back in the middle school, and that's the idea of a net. And I'll go rather quickly over this because most people can quickly see what these are. So go ahead and sketch this one down on your paper and see if you know what would happen if I took this shape and folded it all up. What would it form? I think that one's pretty easy for you guys to see. That's why I wanted to start out with that one. But this one would be a net for a cube. You're going to see 1, 2, 3, 4, 5, 6 squares to form this cube. Okay. Let's try another one. What do you think this one would form? Look at that shape right there. What do you think that would form? I'm going to add a couple dotted lines in there so you can see how that's going to fold together. And I think you guys would agree that that's going to form a nice little triangular prism. I didn't draw it exactly the way this net is, but you can see with this, it has 1, 2, 3 rectangles and 2 triangles as this folds up and folds around to cover that shape. So again, this one would be a net for a triangular prism. And let me see if you can get this one. Draw it like this. Didn't do a very good job there. Should be up a little bit higher, a little bit higher. All right. So not such a good sketch, but hopefully you can see from this one that it looks like this. I'm trying to draw this kind of star-shaped figure here, which is this guy right here. This is the shape of a square pyramid. A square pyramid. It has 4 triangles that fold up to that single vertex, and it has one base that is a square. Let me draw another one for you. How about this shape here? Yep, that's a triangle, or we could attempt at one, but let me put some dotted lines on here that we would use to fold it. What shape would this make? I think you guys can see that it would be pretty much this shape right here. Didn't draw it as good as this is, but you'll see I have 3 triangles that all fold up to meet at the vertex, and 1 triangle down there at the base. Let me draw another one here for you. Oops, let me put this shape here on paper for us so you can see in 3 dimension what we're talking about. And then the final one I want to quickly draw would be this guy right here. I think that's probably the easiest one for you. You can see that this would fold up, or these would wrap around, and we would fold these to form a beautiful cylinder. And that's this net right here, which again, you could see. I could roll it all the way around, or wrap it all the way around, and then circle on bottom and circle on the top. Okay. So go ahead and sketch those out, and I do want to name each one of these because I do want to review some of the names for these shapes. Obviously, this one is the cylinder. This one is a pyramid, and believe it or not, we named this by the shape of its base. This one happens to be a triangular pyramid because it's made up of 1 triangle surrounded by 3 triangles. So again, this is a triangular pyramid. This one over here is also a pyramid. But you can see the shape of the base is indeed a square, so this would be called a square pyramid. Oop, forgot the A. This is a prism because it has 2 parallel and congruent faces. And since the faces are triangles, this is a triangular prism. Triangular prism. Triangular pyramid, triangular prism. The key to know the difference is, or the keys, plural, One key is, you can see in the pyramid we only have one base. In the prism we have always two bases. In the triangular pyramid, all of the other faces are triangles. In the triangular prism, all of the other faces will always be rectangles. A common thing between both of these is 1, 2, 3 triangles because the base had 3 sides. 1, 2, 3 rectangles because the base had 3 sides. If the base had 4 sides, like in this shape right here, we see a base here, and of course the other one's hidden. I can dot that in, I guess, so you see it. Those have 4 faces, therefore we have, or 4 edges, therefore we have 1, 2, 3, 4 faces that are wrap around this. This one, of course, would be a square prism. And because all of the faces are also squares, we also have a special name for this. It is a cube. All cubes are square prisms. Not all square prisms are cubes. This is an example of a square prism because the base is a square, but no one would confuse this with being a cube. Okay. So I do want to give you a chance to draw a couple nets, so I'm going to help you through this. It's going to be very helpful when we do some of our calculations to be able to draw these nets. So first of all, I'm just going to show you, well, let's stay with this shape right here. This guy right here, let's draw a net for that. There's multiple ways of doing it, but I'm going to show you a couple ways to kind of help you out. So the way it's setting here, I can imagine 1, 2, 3, 4 rectangles that would wrap around this. So I'm going to draw it like this with 1, 2, 3, 4 rectangles. That would be 1, 2, 3, 4. So go ahead and draw it like that. And then what I want to do is put a square and a square on either end. The nice thing about this, it doesn't matter where I put these. I'm going to put them like this because this is one of the most common ways that people draw these, so it looks like a T or a cross. It's not the only way that I can do this. I think if I looked at all of your papers as you're drawing these out, I would find somebody that maybe did one that looked like this. That is an acceptable way to draw this, with the squares at the top, if you want to say that top, and at the bottom. Okay? It would look something like this. Another common way of doing that. 1, 2, 3, 4, and then a square that folds up here, and one that would have folded up there. Okay? Those are the two most common ways of drawing those, but I'll quickly just show another example here of these being drawn. And I could do it here and here. The main thing is, when I put these two squares on this one has to be on the right, the way I've drawn it, and one on the left. If I put both of them over here on this side, for example right here and here, then that would be incorrect. Okay? Now, the next shape that we're going to draw a net for is a very common shape in this unit. And it's going to look like this. You're going to see that it has a triangle. But it's not a pyramid, it's a prism. It's going to look like this. So if you need to pause the video to kind of draw this, you'll see, I didn't draw it this well enough, but the what I'm trying to show you in this shape is that on this shape, all of these faces, these three faces here, are all rectangles. There's a triangle in the front and the triangle in the back. And the way I have drawn this, and which is very common in this unit, is for it not to be an equilateral triangle like in this example, but for us to have a right triangle here. Okay? So this one is a triangular prism. And it just so happens that my triangles are all going to be right triangles. So like I did up here, I'm going to show you a couple different ways of drawing this one. I'll start by actually putting the triangle right here, that right triangle. That's this face here. Put him right out here in front so we can see him. Okay. And then I'm going to put what would be the bottom, and if I'm looking at this, what would be the right here, and then kind of at a slant to our left, this guy. Do them like this. And the triangle that's towards the back is going to be here. Okay. Well, this one should be drawn a little bit longer than those other two, so I'm a little bit out of perspective. But this is one way of drawing this one. Okay? Probably the most common way is to draw it so it kind of looks like maybe even an airplane. As I draw this in here. Main thing, oops, messed it up. Main thing we want to see from this, and reason I knew I messed this up is I should see 1, 2, 3 rectangles on this, and 1, 2 triangles. This is obviously a mistake. So I'm going to draw them like that. And you can rotate this if you wanted to. We could draw our triangle here. And the others along here like that. We could do it this way. Kind of square that up a little bit. So make sure, again, you draw each one of these nets. One for the rectangular prism, one for this triangular prism. So one more thing that I want to do today is draw something in what's called a perspective view. Perspective view. In the old days, it might have been called a corner view. Okay. So what I have here are some sketches of some shapes that we're going to do in perspective view. Perspective view. So really, I'm just looking at this cube. Okay? And this is drawn on a two-dimensional sheet of paper, so you can kind of get this, because that's what you're going to see on a test. It's going to be not something that's handed to you and say, hey, draw this. It's going to be on a two-dimensional sheet of paper like this. Okay? Now here's the thing with a perspective view. Okay? With a perspective view, the easiest way to draw these is by using this dot paper that I have here. Okay? And you can see on the previous page I've tried to draw a couple of these, but if I'm drawing this cube in perspective view, I'm going to show you real quickly the method that I like to do. Is go ahead and just draw a rhombus, parallelogram. A kindergartner might even call it a diamond. But draw a diamond shape on your paper. next, put this, or make 3 vertical lines on here, so you're making this look like it is a table. And make them all about the same length. And keep it in about the same length as what you have up there. I might go a little bit longer on each one of these so that they're the same length. Once you have all of their lengths drawn, what I want, or the legs drawn, what I'd like you to do is just connect the bottoms. And guess what? You just made a cube in perspective view. The reason it's called a corner view, it's because what you're looking at, it's as if you're looking at just a corner of this cube. Looking at this corner. That's what's called a perspective view. Some of you may have done some work in your art classes and drawn perspective drawings. So it's kind of similar to that. If you've had any industrial drawing here at the school, then you're a little bit ahead of your fellow classmates when it comes to drawing these. Okay? So that is a perspective view. Now, what I want you to do is let's go ahead and do what's called an orthogonal view. Okay? In an orthogonal view, we always draw 3 views. We always draw this as if we're looking at it from the front. We draw it as if we're looking from the right, and we draw it as if we're looking from the top. Okay? If you have played any around with Google Maps and you've gone to Google Maps and looked at your house, what you can do is you can kind of look at it in a perspective view, and then if you go down to a street view would be an example of orthogonal. In other words, what we're going to do is, let's imagine that this were a building here, sitting on the corner, and you drive right up to the front, and you step out of your car, and you're looking at this building from the front. That's the front view. Now this one's a pretty lame one to draw, but obviously you can see when we see this from the front, all we're going to see is this square. We're going to just see this guy right here. That's our front view. Okay? If you knock on the front door and someone says, oh, wrong door, you need to go to the right side of the building and enter there. Obviously, you're going to take a walk around to here, and you're going to knock on this door here because this is on the right side. When you're standing in the front, the right side is always going to be on the right. That's this side right here. We can't see it when we're looking at it from here. If you go to Street View and look at the front of your house, you're not going to be able to see the right side of your house. That's hidden. That's just where this line here would be. But of course, when we look at this cube, it's going to be pretty lame. It's just going to look like another square. And that's the right side of this. Okay? Now, if someone said, hey, I want you to climb on top of the building, okay, you're going to go up here and look at it from the Google Map view, where you're looking straight down from above as if you're over it with a helicopter or spaceship, and you're going to see the top view right here. The top. Now here's the key. Whenever we have a top view, you're looking at it down from the top. The right side of the top view is always the right side of the shape. Just like when we look at it from the front, the right is always on the right. If I look at it from the top, the front is going to be closest to me. It's pretty obvious on both of these, the right and the front, that the top is going to be on the top when we draw these. Okay? When we draw the right view, the front will always be on our left. Why is that important? Well, because I may not get something as easy what I just drew there. What if I get this shape right here? Okay? And I want to draw a front view, a right view, and a top view for this one. Okay? So again, imagine you're pulling up to this, you're hopping out of the car, here's the sidewalk, you're standing right here, and when you look at this from the front, this building, imagine it as a building, we've just miniaturized ourselves, we're looking at that, and what you're going to see is this building, at least the way I've drawn it here, is going to be 1, 2, 3. Let's say this is you're downtown Cincinnati and you're going shopping. This would be 1, 2, 3 stores wide. And as a matter of fact, on this side it goes up 2. On this side it goes up 3 floors. So we'd go up 1, 2, 3 here, and 1, 2. And it just so happens that both of these are 3 stories high, and only the one on the right is 1 story high. So this would be the front view as we look at this store in downtown Cincinnati. And that's the shape we would see. Now, reminder again, the right side of the front is the right side when we knock on this door and they say, oh, we've got construction going on, please go to the right side of the building and enter in. So you're going to walk along the street here and then go to the right side and look at the building from the right. And here's where it gets a little bit different than what we had before. When we see it this time, we're standing over here from the right, we're actually going to see the face that is this square here, and another rectangle on top of this. When we draw this from the right, we do need to add something on here, and that's this line right here. When we draw this line, you'll see that if you saw this, you did a little search on the internet, looked at some orthogonal views, they're going to darken this in to tell you that there's something going on here. We don't know from the right side whether this rectangle is closer to us or farther away from us. Okay? But there is some distance between this face and that face. We need the right view or the front view to help us see what that right view is. Okay? Now, let's go ahead and do our top view. When we look at this from the top, we're going to see those shapes right there. Okay? And I'm going to draw the T in perspective so you see that. When I look down from this, from the top, this is what I'm going to see. And that's all I'm going to see. When I look at it from the top, I will see this square right here. I will see this rectangle that's down a level from there. When I'm looking at it from the top, the right side is going to be to the right. The front is going to be closest to me, right there. Okay? If you were to draw this like this, same exact shape, okay, this would be incorrect. This is not the top view. And also, if I draw the front view and tried to draw it to look like this, okay, that's also incorrect. Okay? You'll notice when we draw our front view, right view, and top view, we just have horizontal and vertical lines as we draw these. Okay? So that concludes your notes for today. Make sure you go to your agenda for today and check to see what other work that you have to do. Have a good day, and I'll see you tomorrow.